This video is about solving linear equations using a graphing calculator. So today we are going to connect what we've been doing the other days of solving by hand with using a calculator. So first I want to do is I want to solve this first problem by hand. So when I solve here, I have negative 3x plus 3 equals 2 times the quantity x minus 4 plus 1. So first thing we're going to do here is we are going to distribute that 2. So we get negative 3x plus 3 equals 2x minus 8 plus 1. Then we can combine the negative 8 and the 1. So we have negative 3x plus 3 equals 2x minus 7. So I want to move the smaller variable, which in this case is the negative 3x. So I'm going to add 3x to both sides. 3 equals 5x minus 7. We can add 7 to both sides. 10 equals 5x. So our last step here would be to divide by 5 on both sides. So x is 2. Now, instead of always solving by hand, especially when we get problems that are not going to work out to an integer answer, we can use our calculator. If you ever need to round, you should always round to the nearest hundredth, which is 2 decimal places. So the steps to do that, we're going to look at the same problem we just did, but now in our calculator. So I'm going to split my equation in half. So y1, I'm going to put negative 3x plus 3, whatever comes before the parenthesis, or before the equal sign, which is the left side of the equation, and then I'm going to put what's after the equal sign. Now, the calculator, you don't need to distribute, you don't need to combine like terms, you just write it just as is from the right side of the equation. Next, we're going to check our window. Now, because this is the first time graphing on our graphing calculator, we're going to reset the memory real quick. So we're going to hit second plus sign, the number 7, the number 1, the number 2. And it resets our memory. This changes it so everything is okay. So if I hit window, my box is okay. I have negative 10, 10, negative 10, 10. Now, we should not need to change the window at this point. So now we're going to go to y equals. We have y1, y2. See on the calculator we have y1, y2, and a bunch of others. We only have 2 equations, so we're only going to use the first 2 lines. Remember the difference between using the negative sign and the subtraction sign. So the negative sign is if it's in front of the equation, and the subtraction sign if it's between 2 terms. So in the first one, we have negative 3x plus 3. The x is located on a diagonal from the second key. So again, to type that in, negative 3, I go to the second key. The diagonal is this x plus 3. The second equation, 2 parenthesis x minus 4, close parenthesis, plus 1. Once we have that in, we want to see the picture of it, so we are going to hit graph, and the calculator is going to draw the 2 lines for us. So I want to draw a sketch on the coordinate plane that was provided. Make sure when you draw your sketch you add arrows because the lines are going on forever in both directions. I'm going to put a dot at the intersection point. Now we're going to use the calculator to find the intersection point. In order to do that, we hit the buttons second, trace, 5, enter, enter, enter. So I'm going to hit second, trace is next to the graph. It brings us into this menu, calculate. We want option 5. Do not arrow down to 5 and then hit enter. That will mess it up. So we want to hit the number 5. And then we hit enter 1, 2, 3 times. Now it says intersection at the bottom. X is 2, y is negative 3. So we write this as a coordinate 2, negative 3, which in this case means that x equals 2. We always want the x coordinate. So in number 2, we have negative 1/3 x plus 12 equals negative 7. So my y1 is going to be negative 1/3 x plus 12. My y2 is going to be negative 7. So we're going to go to y equals again. We're going to hit clear by both equations. So y1 has a fraction, so we're going to put parentheses around it. So parenthesis -1 divided by 3, close parenthesis x plus 12, close parenthesis. Y2 is going to be -7. Once we have those equations in, we don't need to check our window because we didn't touch the window. So we just hit graph, and we see our graph here. So we're going to draw a picture of our graph. Here is our intersection. Then we're going to find that intersection. So we're going to hit second trace, option 5. We hit enter 3 times. So that intersection point is going to be 9, -7. So x equals 9. In the next problem, we have 10 times the quantity x plus 2 equals -1 plus 2.32x. So y1 is going to be 10 times x plus 2. Y2 is going to be -1 plus 2.32x. So in y1, I'm going to clear these out. We're going to type 10 parenthesis x plus 2. And in y2, -1 plus 2.32x. And we're going to hit graph. Now we see our graph, so we can draw our picture. We have our intersection point. So to find that intersection point, second trace, option 5, enter, enter, enter. And we're going to round that to -2.73, comma, -7.34. So x is going to equal -2.73. Now remember, we also talked about special cases. So let's see what happens with special cases after we solve and graph. So first we're going to solve both equations by hand and then look at what their graphs look like. So in the first equation, we have 2x minus 10 plus 5x equals 7 times the quantity x minus 5 plus 25. So I'm going to distribute this 7. So we have 2 minus 10x plus 5x equals 7x minus 35 plus 25. So we can combine these x's, 2 and 5, to get us 7x minus 10. Then we can combine these numbers, so we have also 7x minus 10. Now, the variables are the same on both sides, so when I subtract 7x from both sides, I'm left with -10 equals -10. Because these numbers are the same, this is infinitely many solutions. In number 6, we see 4x's on both sides, so we can subtract 4x. -12 equals 0. That is not true, so this is a no solution. So let's see what the graphs look like for these. So in number 7, when I split my equation, I have 2x minus 10 plus 5x as y1. I have 7 times the quantity x minus 5 plus 25 as y2. We're going to clear out y1 and y2. y1 is 2x minus 10 plus 5x. 7 parenthesis x minus 5 plus 25. I'm going to hit graph. So notice there's a blue line, and then the red line replaces it. So it looks like there's only one line because these lines are overlapping. So whenever you see only one line on your equation, on your graph, this is the special case of infinitely many solutions. So let's look at our last problem to graph. So here we have 4x minus 12, and we have 4x. So in y1, we're going to type 4x minus 12, and in y2, we're going to type 4x. When we graph this time, we have two lines that have the same slope, they look like they're going in the same direction, so they're never going to intersect. These are parallel lines, and parallel lines have no solution. So we can draw our graph here, and then we would have no solution. So, as we saw today, there are 3 things that can happen when we graph. So the first thing that can happen is one solution, and that is when our lines intersect, and we identify that intersection point, and we get x equals a number. Our second one is no solution. This happens when we have 2 parallel lines. And our last one is infinitely many solutions, and this happens when we only have 1 line on our graph.